Okay guys, today we're working on 2.6, transformation of functions. Of course, a lot of this you can do on your graphing calculators, but it's nice to be able to look at the equation and graph the parent function and use that to generate some other graphs. We're going to take a look at vertical shifting, moving the graphs up and down, horizontal, left and right, reflection, flipping them over the x or y axis, stretching or shrinking, and then of course, even and odd. Really, almost everything we can do on our graphing calculators, but like I said, I'm going to do some of this by hand here today. So first up, our vertical shifts, those are the easiest. If you are adding or subtracting something at the end of the function, you move your graph up or down. So you can see on mine, of course, are in colors, the blue and the red. The blue is your original function. On the left-hand side of the screen, if you add a value, move the graph up to the red one. On the right-hand side, our original blue function, we subtracted a value at the end of the function, so it moved it down. So pretty straightforward for the vertical shifts. So I'm going to first just graph our parent function, what we consider just the x squared without the up 3 before we get into it. So I'm just thinking about my parabola. I can put 0 in, 0, 0. I put 1 in, 1 squared is 1. Negative 1 squared is 1. And I'm going to put another pair of points in. 2 squared is 4. Negative 2 squared 4. So I'm just going to dash this on. This is kind of our parent function, and I'm going to use that to get our new graph here, where now I'm going to take that purple parabola and just move all of my points up 3. So up 1, 2, 3, up 1, 2, 3, up 3, up 3, and of course up 3. Like I said, you could type both of them into your graphing calculator, but of course we're trying to do it off of our shifting. Now, -2, we're going to move our graph, of course, down to. I'm not going to redraw the parent function because I got it on the first one there, my purple parabola. I'm just going to take that purple parabola, vertex at the origin, 0, 0. I'm going to move it down to. I'm going to move my -1, 1 point down to. My -2, 4 point down to. I'm going to keep going here to the right side. My 1, 1 point, I'm going to move that down to. And then 2, 4, I also move down to. Nice, easy shifting of a parabola, and just like that. I know the notes look long, but really they go quick. There's just so many graphs on here. So here, of course, just a list in your notes of our basic parent functions. We've seen the lines, we know our quadratics. Absolute value, of course, make the v. We've seen our square root functions here, this on the right-hand side, that kind of half of a sideways parabola, and we will get into some third-degree functions here eventually, too. Now, horizontal shifting left and right. This time, the values are in the parentheses, added or subtracted 2x. If you subtract a value, that ends up moving it to the right. And if you add a value, it moves it to the left. So let's do one of these transformations. So again, I'm still thinking about my original. I'm going to put it on so it's in front of us. My original parent function, that purple parabola we first started with. I'm just going to leave the points there for right now, and we'll shift those. So of course my +4 is going to move this 4 left. So I'm going to take each of my purple dots and just go 4 left. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Got it. 4 and 1, 2, 3, 4. Nothing too shabby there. Okay, same thing. I'm going to put my purple dots on the parent function again for our parabola. Let's see, 2, 4, -2, 4. And this time, of course, our -2 is going to move our graph 2 to the right. 1, 2, 1, 2, 1, 2, and 1, 2. Got it. And like I said, worst case, you can always graph them in our calculators, but hopefully we can do it doing the shifting from our parent functions. Okay, sketch the graph. So first things first, of course I'm going to put the parent function on. Let's call it g of x or something different, or square root of x. So of course I'm just thinking about a few points in the t-chart. Square root functions, we know our domains. You can't square root a negative number. So I'm going to start with 0, square root of 0, 0. Square root of 1, 1. And then I'm going to go to 4, just so I know my drawing skills. Square root of 4, 2, get a nice whole number there. Not that you couldn't use 2 for x. I'm just trying to make my life easy here. So there's our parent radical function. So this one we have 2 shifts. The -3 with x is a horizontal shift. It's going to move your graph 3 right. And then the 4 at the back is going to move it up 4. Now it doesn't matter which you count first, the right or the up. we're gonna get the same thing. I'm gonna go right and then up. So right 3, I'm starting at 0, 0. Right 3, up 4. And then I'm gonna do my 1, 1 point, right 3, up 4. And I'm gonna do my 4, 2 point, and I'm gonna go right 3, up 4. And there is our new shifted graph. Feel like I should ask if there's any questions, but hey, we're on the video, so we're just gonna keep going forward. Okay, next up, let's talk reflections. So anytime you have negatives involved, that is gonna reflect your graph or flip it over an axis, so to speak. Negative in front reflects over the x-axis. So you can see on this first left graph, your blue, our original function, our blue one, they counted, you can see these congruent marks here, throw back to geometry, you are counting that same amount the opposite or underneath or below the x-axis. So you want to have the same distance above and below the x-axis. Same thing if you are reflecting over the y, you see your congruent marks here, same amount of units to the left, same amount of units to the right on your y-axis. So just be aware of that. Let's graph some reflections. So again, we've got our parabola. I'm going to put our parent function on, our 0, 0, 1, 1, negative 2, 4, 2, 1, 1, and 2, 4. I feel like I plotted that a lot. And then of course our negative in the front, that means it reflects over x. So I'm going to start clear on the left here at negative 2, 4. It's 4 units above the x, so I'm going to put it 4 units below. So I'm going to plot negative 2, negative 4. Negative 1, 1, you're 1 unit above, 1 unit below. 0, 0 is on the x-axis, so it stays on the x-axis. 1, 1 is 1 above, so I go 1 below. 2, 4, you're 4 units above the x, now you're 4 units below. Pretend I hit that point. All right, let's do this square root of negative x. Again, I'm going to put the purple parent function on that we graphed earlier. I had 0, 0. I'm just going to do my parent here. So remember in my t-chart, we had 0, 0, 1, 1, 4, 2. 0, 0. Got it? Okay, so now let's do our transformation, of course, on this one. Our negative in there means this time we are reflecting. It's not in front, it's with attached to x. So this is over the y-axis. So now I'm going to count the same left and right. So I'm going to start at 0, 0. It's on the y-axis, so I'm going to keep it there. 1, 1 is 1 on the right side of the y, so I go 1 to the left. 4, 2 is 4 on the right side, so I'm going to go 4 to the left and plot negative 4, negative 2. Got it. There we go. And as always, you can always check these in your graphing calculators. Okay, so we have done horizontal left and right shifts, we've done vertical up and down shifts, we've dealt with the negatives and the reflections. Let's get into the vertical stretching and vertical shrinking. So of course, how you know you have a vertical stretch or shrink, you multiply by a value in front of your function. So if that value is over 1, it stretches it. If it's between 0 and 1, it shrinks it. So for instance, if you have that parent function we've been using a lot, the parabola, and now all of a sudden I put a 2 in front, 2x squared, double 1x squared. So that doubling is going to stretch the graph out. If I were to make that a half x squared, now it's half as much. So the half would shrink it. So that's the next thing we're going to take a look at here. So flip the page, we're cruising around. Okay, use the graph of f of x squared to sketch the graph of the following. So again, I'm going to start with the parent function. So just my normal t-chart we had earlier, my negative 2, 4. I'm just going to list the points here, my negative 1, 1, 0, 0, 1, 1, 2, 4. Bottom on here. Got it. Now, this time, just to get the ordered pairs, and some of you can just do this, of course, on your graphs. So this time to get, of course, my g of x function, my 3x squared, I'm just going to kind of add it onto the t-chart here. I'm going to take all the y's and I just times them by 3. So 4 times 3, okay, I don't know if I'll fit that one on the graph. 1 times 3, 0 times 3, 1 times 3, 4 times 3. So I'm going to plot the point negative 2, 12. Well, I'll plot it. We're kind of off the graph grid. Let's just estimate it. There we go. Negative 1, 3, 0, 0, still the vertex. And then I'm going to have 1, 3. And then I'm going to have 2, 12. it. There we go. So you can see it stretched the graph out or made it skinnier is kind of how I think of that. Now the third is going to shrink it. I'm going to go ahead and put that on the t-chart too and see what we can do for the y coordinates. We might have a little bit of fractions here. So now I'm going to take all those purple y coordinates and we're going to times them all by a third. So 4 times the third, 1 times the third, 0 times the third, 1 times the third, 4 times the third. And we'll plot those. Now 4/3, I would maybe think of that as the mixed number 1 1/3. So I'm going to plot the point -2, 1 1/3, -1 1/3, 0 0, 1 comma 1/3, 2 comma 1 1/3. So you can see this time your parabola is widened out. So multiplying by 3 stretched it, multiplying by a third shrunk it. And of course you can always see that on your calculator if you really get stuck. Okay, oh boy, we got all sorts of good stuff here. So again, let's first just jot down what we all have happening as far as our transformations. So I see the -3 with x, so that's going to move it 3 right. Got it. I see the +1 really. We're used to the +1 at the back, but it doesn't matter. That moves it up 1. We've got a negative on it, because again, really, if that's messing with your mind, think of it as this form, the +1 at the back. We have the negative on front, so it's going to reflect over x. And then, of course, we've got the 2, so we have a vertical stretch. Okay, so we have all sorts of good stuff. I'm going to go ahead and plot our parent function again, -1 1, -2 4, 1 1 2 4, just so that's kind of in front of us. Now the 3 right, the 1 up, that's not going to be difficult at all to do, of course. The reflecting, we're going to flip it over, and then of course the vertical stretch. Now I think the stretch is probably the toughest one to do. We're going to double those y coordinates. So again, I'm going to start with that. So I'm just listing my points again. 0 0 1 1 2 4. Got it. And now of course if I do the stretch, I'm going to double all of these. So 4 times 2, 1 times 2, 0 times 2, 1 times 2, 4 times 2. So I'm going to start with plotting the stretch part. I'm just going to check it off that I did it here. So -2 8, -1 2, 0 0, 1 2, 2 8. So we did that. Now from the blue dots, I'm going to do this all. I think I can do it all together. I'm going to do the blue dots, 3 right, 1 up. So I'm going to start on the far left one, 3 right. I didn't mean to plot that. Come on, board. Okay, here we go. 3 right, 1 2 3, and then of course 1 up. 3 right, 2 3, 1 up. So from the blue dots, 3 right, 1 up, 3 right, 1 up, 3 right, 1 up. So there's my, I'm going to check these guys. Got it. And now, of course, we have to reflect it over the x-axis. So I'm going to do green for my final graph here. So for our final graph, of course, we're going to keep our little vertex there. And I can see I'm going to start with this 2 comma 3. I'm 3 units above, so I put it 3 units below the x. 1 comma 8, I'm 8 above, so I'm going to put it 8 below. And then I'm looking at the 4 3 dot. 4 3 is 3 above, 3 below. And then 5 8, 8 above, 8 below. Whew, that was a lot of shifting there. So again, my advice is do any stretching or shrinking first, then move it left, right, and then do your reflection at the end. You'll get the same graph if you did it in a little different order, but just a little pro tips there for you. Okay, horizontal, shrinking, and stretching. So this time if you are multiplying the value directly to x in the parenthesis, that's going to shrink your graph or stretch your graph. So you can see here on the first graph on the left, that is a shrink, because it goes from the blue to the red. The red skinnier is scrunched up beneath there. Now here's the tricky part, by a factor of 1 over c. So if your value, let's say, was 5, it shrinks by amount of 1/5. And then you can see the right graph is a stretch. horizontal stretch to get specific, because of course our original functions, the blue, they stretched out to the red, and again, it's that 1 over c factor. Now if c is between 0 and 1, so let's say it's a half, well if I do 1 over a half, that's really 2. So that's why it's kind of widened out, so to speak, versus the other one where you have the fifth, why it's shrunk up on the left-hand side. So let's do a couple graphs of this. So this is really going to test my drawing skills here, kids. Let's see what we can do. So the graph of f of x is shown below, so over there on the right-hand side, the red. Sketch the graph of each function. Okay, all right. So you've got the 2 on here. So let's take a look at that. So this time, of course, we're going to, it's with the x, so I know it's a horizontal. I'm thinking about it's 1 over that value. So I'm thinking about a half, so it's going to be half as y, aka a shrink. So here's what I'm going to try to do on this one. I actually think it might be easier if we just draw it over top of the existing graph instead of trying to do a whole separate one. So of course I'm looking here at the middle, but now instead of having my triangle, I'm looking between 0 and 1, I'm looking at this guy, I want it kind of half as much. So I'm going to put a point between 0 and a half. I'm just going to erase this where you know I'm taking a look at this right now, and I'm going to go ahead and draw in half as much. So you end up with double the amount of triangles in between each unit. So 1 and a half, pretend I do those straight, 2 and a half, so on and so forth. Don't judge my drawing. Okay, we got it. So you can see it's shrunk. There's double the amount of triangles in it. Whew, okay. Now, let's take a look at this guy. This one I might redraw so we don't make such a mess over that graph. So of course, the half is on the x. If I do 1 over a half, that's really 2. So now we're doubling it out. So I'm going to go ahead, you guys keep your drawing there. I'm just going to erase this quick so we can take a look at the original red again. And just so we don't make a mess here, let's actually draw this one separate. I think it's going to be hard to put them all on the same graph. So I've got my 1, my 0, okay, so on and so forth. Let's get that purple dot off of there. I'm going to mark a couple others here. 2 goes out to 3, -1, -2, -3. Okay, so this time, of course, your original triangles between 0 and 1, well, we're going to double it out. So our first triangle is going to go all the way from 0 to 2. And then it would be 2 to 4. 0 to -2. -2 to -4. So it widens it out. Nobody judge my drawing skills. Okay, last up, let's get into this even and odd functions. So even and odd functions, we talk about that a lot, especially in trim pre-calc, of course. Even and odd functions, there's 2 different ways you can tell if it's even or odd. You can test it algebraically, meaning if you replace x with a negative x, you simplify, you get the exact same original function, even. So that's what all of this says. So replace x with a negative x, simplify, results the same as the original function, even. Another way to tell it from the picture, back to geometry here, is symmetric over the y-axis. So you can fold it over that green y-axis and it matches up, you get the exact same graph. Odd, same type of place to start if you're doing it algebraically. Replace x with a negative x, simplify, if you get the opposite, it's odd. Now, what we mean by opposite in math, of course, opposite in science. So all your positives switch to negatives, negatives to positive. Now, it is also symmetric about the origin. That sometimes can be a little bit trickier to see. So what that means, I'm going to spin this graph here. If I can rotate it 180, so half a circle, doesn't matter which way you rotate it, you get the exact same graph. So have this red curve in front of you. If I spin it, there's 90, 180, whoops, weird up, 180. It's the same graph I started with. So I've actually had kids rotate their graphing calculators on their desk to see the graph to do it. I don't care how you do it, as long as you can figure out whether it's even or whether it's odd. So I'm going to do these, of course, algebraically, and then we'll just take a look at a couple of them on our calculator. So they all start the same. Replace x with a negative x. Now you have to be super conscientious of your signs. 5 negatives negative. Plus negative x, let's just make it minus x. If you get the exact same original function even, that's not our case. If we have opposite signs, positive to negative, I think we got it, then it is odd. We'll look at the graph of some of these here in a second. Let's do this guy. I'm going to replace x with a negative x. I'm going to simplify. Watch your order of operations, of course, exponent first. So I'm going to do 4 negatives, positive. If I get the exact same original function, which I did, even. So when we look at that graph, I know it's going to be symmetric over y. Okay, let's do this guy, same thing, replace x with a negative x. And simplify. 2 times the negative x. Exponent first over here, 2 negatives makes a positive. So not the exact same original, not all signs are switched, so not odd, not opposite, so we have neither. Okay, so let's just take a look at a graph. We're not going to do them all. Let's just look at maybe the first one here. So of course, just type it in your y equals. There's nothing fancy here. X to the 5th. And then of course, plus x. Now there's the graph. I'm going to steal the picture. Let me move it over here a little bit so we can see it, and then we'll delete it out of our way. So we already know what's odd, of course, from our algebra. If I spin it 180 degrees, either direction, 90, 180, there it is. It's the same graph that we started with. So that's how you can tell it from the graph. Now if I go through and graph part B, let's put that one in, which we know is even, 1 minus x to the 4th. Let's take a look at this one. I'm going to steal the picture here so we can talk about it. So on this one, of course, we can see if I go through and I look at this y-axis, if you fold it over the y-axis, it matches up, it's symmetric, therefore it is even. So easy way to tell. I think evens are especially easy to tell on the graphs. So just read the directions close. Sometimes it wants algebraically, sometimes graphically, sometimes it says just figure it out. As always, follow your directions. All right, have a great day, everybody.